Okay, we'll get back to section 11.2 now. We're talking about series, and geometric series, that's going to be an important series in everything for chapter 11. So let's take a look at that. A geometric series is a series of the form, we have the summation as n equals 1 to infinity of a times r to the n minus 1 power. Okay, so if n is 1, I got a times r to the 0, anything to the 0 power is 1, so I got a times 1 is a. If n is 2, I got a times r is the second term. If n is 3, a times r squared would be the third term, plus etc. Okay, I'm heading out towards infinity. So this is an infinite series. A can't be 0, by the way, because otherwise I'm adding up 0 infinitely many times. As a note, this series here, the summation as n equals 1 to infinity of a times r to the n minus 1, that is equal to the summation as n equals 0 to infinity of a times r to the n. Okay, and sometimes we're going to want to start a geometric series at 0 as opposed to 1. Just for some of these problems, they're going to look like that. Okay, they mean the same thing though, right? So if n is 0, I get a times r to the 0, or a times 1 is a. If n is 1, a times r would be the second term. If n is 2, ar squared is the third term, etc. Okay. There's the theorem next, which is really important. It says that the summation as n equals 1 to infinity of a times r to the n minus 1 is convergent if the absolute value of r is less than 1. Okay, and to find the sum, you take a divided by 1 minus r. If the absolute value of r is some number that is 1 or more, then the series diverges. So if you add up all infinitely many terms, you get infinity or negative infinity. Okay? There's a quick proof of this here. So let's let S sub n be the nth partial sum. Okay, that was from the previous page there, 11.2. So I'm looking at the summation as I equals 1 to n of a times r to the I minus 1. Okay, now this is going to be a finite series because I'm ending at n. So the first term, when I is 1, I get a times 0 is a times r to the 0 is a times 1 is a. When I is 2, a times r is the second term. When I is 3, 8r squared is the third term, right, etc. I'm ending at n, so the last term here would be a times r to the n minus 1. Okay, so I got n terms here. There's n of these things that I'm adding up. Now, if r is equal to 1, then the summation as n equals 1 to infinity of a times r to the n minus 1, that's by definition the limit as n approaches infinity of the nth partial sum. Okay, here's the formula that I'm using for the nth partial sum for this problem. So we got the limit as n approaches infinity of the summation as I equals 1 to n of a. R is 1, right? So 1 to any power is always 1. And in this problem here, like I'm adding up a n times. Okay, well that's the same as a times n, right? And the limit as n approaches infinity of a times n, that's going to be infinity or negative infinity depending on the value of a. Okay, so you're going to have a divergent series if r is 1. Okay, now what if we take r to not be 1? Then r times s sub n, here's s sub n. So if I multiply all n of these terms by r, I'm looking at a times r plus a times r squared plus a times r cubed plus etc. all the way up to a times r to the n power. Okay, now the next thing I'm going to do is I'm going to take s sub n, this guy here, and subtract r times s sub n. So I'm looking at a And then a times r minus a times r, that's 0. ar squared minus ar squared, that's 0. ar cubed minus ar cubed, that's 0, right? And so these terms are going to cancel except for the last one, okay? So I'm subtracting r times s sub n. Well, the term that's previous to this is going to be a times r to the n minus 1 minus a times r to the n minus 1. Those are gone. And then minus a times r to the n. Okay, so s sub n minus r times s sub n, that is equal to a minus a times r to the n. And let's see, on the left, let me go ahead and factor out an s sub n. On the right, let me go ahead and factor out an a. And then when we divide both sides of this equation by 1 minus r, a divided by 1 minus r times 1 minus r to the n, that's equal to s sub n. Okay? Then if the absolute value of r is less than 1, then the summation as n equals 1 to infinity of a times r to the n minus 1, that is equal, by definition, to the limit as n approaches infinity of the nth partial sum. Like, here's the formula that I've got for the nth partial sum currently. Anything involving n has to stay inside the limit. Anything not involving n can be treated as a constant that can come outside of the limit. So a divided by 1 minus r, that's a constant that can come outside the limit. Now, the absolute value of r is less than 1. Okay? So if r is like 1/2, let's say, 1/2 to the n power, that'd be the same as 1 divided by 2n, which is 0. And you got 1 minus 0, that's 1. So a divided by 1 minus r, that's going to be the answer, okay, which is the value of this series here, okay. If the absolute value of r is greater than 1, okay, like if r is 2, we're looking at 2 to the n power. N is approaching infinity, so that's going to be infinity. Okay? And infinity times any other number is going to be infinity, or negative infinity, right? So be sure that you know this this theorem here. Okay, this is going to be really important for a lot of things in chapter 11 and in chapter 11 here. Okay, it's we're talking about a geometric series there. Okay, so let's take a look at some examples of this. In this first example, suppose that I have the summation as n equals 0 to infinity of 3 divided by 2 to the n power. Okay, so if I factor out a 3, then I'm looking at 1/2 to the n. That'd be the r value. Now I'm starting at 0, so I need to make sure I'm in the form a times r to the n, which, yes, I'm in that form. A is 3. R is 1/2. This is going to be a convergent series because the absolute value of r is less than 1. So 3 divided by 1 minus 1/2, that's 3 divided by 1/2. If I flip the denominator, I get 6. So if I add up all infinitely many of these terms, the grand total is 6. That's what I'm saying. So, the first term would be 3. The second term would be 3/2. The third term would be, the first term when n is 0, that'd be 3. When n is 1, I get 3/2. When n is 2, I get 3/4. When n is 3, I get 3/8, right? So if I add up all infinitely many of those terms, I get 6 as the answer. Okay, let's try another one there. So in this next example, suppose I have the summation as n equals 1 to infinity of 7/9 to the n power. Now, one of the things I'm looking at is if n is 1 or n is 0, right? Because I need to make sure that my series form is correct here before I go and use the formula. Okay, so let's see, if I'm starting at 1, I need to make sure that I'm in the form a times r to the n minus 1. I'm not in that form. Okay, so if I factor out a 7/9, I got 7/9 times 7/9 to the n minus 1. Okay, now I'm in that form. A is 7/9, r is 7/9, and a times r to the n minus 1. And 7/9 is a number that's less than 1, so I know that this series is going to converge. Now, to find what it converges to, you're going to take a divided by 1 minus r. A is 7/9, divided by 1 minus r is also 7/9. 1 minus 7/9 is 2/9. 7/9 divided by 2/9, when I flip the denominator, the 9's cancel, I get 7/2 as the answer. Okay, so in other words, if I add up all infinitely many of these terms, I get 7/9 plus 7/9 squared plus 7/9 cubed plus 7/9 to the 4th. The grand total would be 3.5. Okay. Here's another one. So sometimes you'll have a series, and they're not using summation notation. Like in this example, what if we have 5 minus 10/3 plus 29ths minus 40 27ths plus etc. Like what would be the total if I add up all infinitely many of these terms? Well, using series notation, I'm going to have the summation as n equals 1 to infinity of a times r to the n minus 1. Okay, so a would be 5. And 5 times what number gives you negative 10/3? Well, if I take 5 times negative 2/3, I get negative 10/3. So negative 2/3, that's going to be the r value. And I want to raise that to the n minus 1 power. So now I think I came up with this formula, but I want to check and make sure that I'm getting term by term what I have written here. So if n is 1, I got 5 times negative 2/3 to the 0 power. Anything to the 0 power is 1. 5 times 1 is 5. That's the first term. When n is 2, 5 times negative 2/3 to the first power, that's negative 10/3. That's the second term. Okay. When n is 3, negative 2/3 squared is 4/9. 4/9 times 5 is 20/9. Okay, and I'm going to have an alternating series, meaning that it alternates sign, plus, minus, plus, minus, plus, minus. And that's okay. I can still know that this series will converge because r is negative 2/3. The absolute value of negative 2/3 would be 2/3. That's less than 1. Okay, so a is 5 divided by 1 minus r. R is negative 2/3. 1 minus negative 2/3 is 5/3. Okay, and if I take 5 divided by 5/3 and I flip the denominator there, the 5's will cancel and I get 3. So if I add up all infinitely many of these terms here, I got 5 minus 10/3 plus 29ths minus 40 over 27 plus etc. The grand total from adding all infinitely many of these terms here would be 3. Okay. Here's another example. Okay, so what if I had the summation as n equals 1 to infinity of 2 to the power 2n times 3 to the power 1 minus n? So the goal with this is to try to make this look like a geometric series. In other words, I have the summation as n equals 1 to infinity of a times r to the n minus 1. That's what I'm trying to get inside. Well, 2 to the 2n, that's the same as 2 squared to the n, or 4 to the n. 3 to the power 1 minus n, that would be the same thing as 3 to the power negative n minus 1. Okay, and so that's the same thing as 1 divided by 3 to the power n minus 1. Okay, now the next thing I'm going to do is I'm going to factor out a 4. 4 times 4 to the n would be 4 times 4 to the n minus 1. So then the r value is 4/3. Okay, now 4/3 is bigger than 1. So I know that this series here is going to diverge because of that. Okay, so my answer would be a divergent series. Now, I don't use the formula and, a divided by 1 minus r there. I only use that formula if I've got a convergent series to find out what it converges to. Otherwise, if the absolute value of r is 1 or more, I know that I'm going to get infinity or negative infinity when I add up all infinitely many of these terms here. So that would be a divergent series. Okay, here's let's just do one more here. So 2 plus 12/5 plus 72 over 25 plus 532 over 125 plus etc. Like, what is the grand total from that? Okay, well, let's see. If I rewrite this as a geometric series, which it is, okay, then now when I'm writing it as a geometric series, I can write it in the form the summation as n equals 1 to infinity of a times r to the n minus 1, or the summation as n equals 0 to infinity of a times r to the n. Like, both of these mean the same thing. Okay, you just want to make sure that, if you're starting at 0, the power of r is n. If you're starting at 1, the power of r is n minus 1. Okay, so let's suppose that we start this at 0. Now I need to make sure I'm getting term by term what I see here. A is 2. That's the first number. And r, okay, so 2 times what number gives you 12/5? Well, if I take 2 times 6/5, I get 12/5. So r would be 6/5. And let me check this. So 6/5 to the 0, that's 1. 2 would be the first number there. If n is 1, I get 2 times 6/5, that's 12/5. If n is 2, I'm looking at 36 divided by 25. 36 times 2 is 72 divided by 25, plus etc. Okay, now because 6/5 is the number that's bigger than 1, I can know that this series diverges. And that's going to be my answer. Okay? All right, we'll go ahead and stop right there, and I'll pick up with this example in the next video.